Greetings, A-level chemists. We've got another acid-base question, and let's have a look at what's going on. So it looks a little bit more meaty. A student's doing a titration, and they're gradually adding that volume and concentration of sodium hydroxide to this weak acid, propanoic acid. Okay, what I'm going to do, even though it's not really asking for it, I'm just going to write out my equation because it might come in handy. So that's my weak acid, and here is my strong base. And I am going to get sodium propanoate, that's my salt, and water being produced. Okay, so I'm guessing we're making a buffer in situ. So let's have a look where we go next. So we know the concentration and volume of the propanoic acid, and it tells us we're recording or tracking the pH throughout the process. Show through calculations that we need that volume of sodium hydroxide to fully neutralize the acid and reach the equivalence point. Okay, if in doubt, work in moles. In fact, I'm not in doubt, but I'm going to work in moles. So, where do we start? Let's have a look at what's going on. So we've got a conical flask with a set volume of NaOH in here, and we're titrating it against sodium hydroxide, which is coming from the burette, right? So let's work out the number of moles. N stands for the number of moles of propanoic acid. CH3CH2COOH. Okay, so let's work out this number of moles first, because that's the number of moles we have literally in the conical flask. So how do we do this? Remember that N equals C times V. So N equals the volume, which is 25 centimeters cubed. So we divide by 1,000 to get decimeters cubed. And then the concentration is 0.0810. So what do we get when we process this? Let's get my calculator up on the screen. So 25 over 1,000 times 0.0810. Fraction. Don't want to do it as that. Let's leave it as a decimal. So we're going to get 2.025 times 10 to the minus 3 moles of that acid in the conical flask. Okay. So if we've got that number of moles of acid in the conical flask, well, that's clearly the number of moles of sodium hydroxide we need to fully neutralize the acid. So where we're going to go next is we need to show that we need this volume of sodium hydroxide. Okay, so let's work out the volume of NaOH needed to neutralize. And let's go from there. Okay, so this number of moles is going to be equal to the number of moles of sodium hydroxide at the neutralization point or the equivalence point. Okay, so if we look at the formula that we first stated, N equals C times V, we're trying to work out the volume. So if we're trying to work out the volume, let's rearrange and divide through by the concentration. So N over C equals the volume needed. Now, we know the volume, we know the number of moles, and we know the concentration of the sodium hydroxide. So let's just sub these values in to this equation. So the number of moles at the equivalence point is going to be this number of moles. So V equals 2.025 times 10 to the minus 3. And then the concentration is given to me in the question. It's 0.1. Okay, well, let's process this. So if we're dividing by 0.1, we're timesing by 10. So what do we get? We get 0.02025, and that's in decimeters cubed. So therefore, we times that by 1,000 to get that into centimeters cubed. So the decimal place is moving 1, 2, 3 places to the right. So this becomes 20.25 centimeters cubed. Okay, well, if we round up to 3 significant figures or 1 decimal place, we can say that the volume is indeed 20.3 centimeters cubed. So that's how much sodium hydroxide is needed. That's the volume of NaOH needed at the equivalence point. Okay, see you later.